All right, let's get into testing our probability. Our probability table over here on these pair of six-sided dice, or rather, this pair of six-sided die. Ha, that's the right way to say it. All right, so if we look at this table, we have 11 possible results when we roll a six-sided die. We could roll a 2, a 3, a 4, 5, 6, 7, 8, 9, 10, 11, or 12, right? If you roll two six-sided die, minimum you could roll is 2, where both of the values on the die are 1, and a 12 when both of the values on the die are 6. All right, if we count that up real quick, that means we have 11 possible numbers that we can roll. So what I'm going to do is I'm going to create an integer array. We haven't done that in a while, but yes, I'm going to create an integer array called die result. And I'm going to set that equal to an integer array that has 11 spots. All right, so 0 through 10 are going to be the indices on this array, and those will relate to the die value minus 2. All right, so 2 minus 2 is 0, so that'll go in the 0th index. 3 minus 2 is 1, it'll go in the first index, second, third, fourth, blah, blah, blah. 12 will go in index 10. That's essentially what that boils down to. All right, I'm going to create a new integer called die value, which we will use in a loop that we're about to write up. I'm going to create a new integer called rolls, and I'm going to just set that equal to, let's do 100,000 for now. Then I'm going to create a for loop that says for int I equals 0, I is less than rolls, I plus plus. So this will loop 100,000 times because that's the value of rolls. And we'll say two things. Die value is equal to our dice dot die roll. Right, I believe that's how we called it, right? Die roll. Yep. And the integer we'll give it is 6 because we want a six-sided die. Plus dice dot die roll again 6 because we have two dice, so we have to add them together. All right. Then die result of die value minus 2 should increment by 1. All right, so what is happening here? Well, when we created our die result array, we created an array of 11 integers. Now, the default value for those integers is 0. So they all start off at 0, right? And what we're doing 100,000 times over here is we're rolling two dice, summing their total, and then in the section that represents that total, we're increasing the count from 0 to 1 to 2 to 3. We're just increasing it by 1, right? And this is just to record how many times we roll a certain value. All right, so if we roll 2, we increase the count of how many times we've rolled 2 by 1. And then if we roll a 7, we increase that by 1. Then we roll a 6, we increase that by 1. So we can get a count of how many of each we've rolled so far. Now what I'm going to do is I'm going to create a double array. And we're going to call this practical prob. And this is also going to be an array with 11 spots, 11 indices, 0 through 10, just like before. We're going to do another loop that loops for int I equals 0, I is less than 11, I plus plus. Then we'll say in this loop, practical prob at index I is equal to, and we're gonna have to cast this to a double so that we can use double values from integers. So we'll get the double of die result at index I, and we'll divide it by our rolls, right? Because like we need to divide how many times we've rolled something by the number of times we've rolled total, and that'll tell you how what percentage of the time you've rolled that value. And then to get a percent, we just need to multiply this whole thing by 100, which we could just multiply it by 100 on the end. The order of operations will uphold, so it'll be the die results divided by the rolls, and then it'll multiply it by 100 so that we can get that percent. Then what we're going to do is we're going to say system.out.printf, and we'll say result of %d rolls with our rolls. We'll have a for loop, int I equals 0, I is less than 11, I plus plus. And then in this loop, we will just print out our rolls. And here's how we're going to do it. We're going to say system.out.printf, and again, %d was rolled %d times probability is equal to %.2f % backslash n. Don't worry, I'm going to go over what all of this means. Then in this value, I plus 2. Then we'll put die result at index I. Oops, I'm going to need to give us slightly more room again. Comma. Practical prob at index I. Alright, so we use this printf twice, and I just want to discuss quickly what this means. Alright, printf is what's called a formatted print. I believe we might have talked about it already, but in case we haven't, let's just discuss. A formatted print, which is essentially you list a string, and that string can have a mixture of words and then these format flags. And format flags are %signs followed by a letter that represents what type of data that they want to insert into this flag, and sometimes some other qualifying information. So when we say %d, this means we want a number, all right? And so right here, when we and this is a number like an integer, like that type of number, a non-floating point number, so one that's a whole number essentially. So when I say %d and then I put rolls, well, rolls was an integer, so that would be a non-floating point number, and so it'll put result of 100,000 rolls. The reason we do it this way is because it's easier than concatenating strings. That's really all it is. All right, and that's just why we put it there. Then over here, for this formatted string, %d was rolled %d times. The probability is %.2f, %%. Okay, what does this mean? Well, the great thing about formatted print is if you put multiple percents flags, you will substitute in for them in the order that you list the arguments after that first string. So %d, that first %d gets its first argument, I plus 2. So this will say 2 was rolled d times, and then it'll be, 3 was rolled, 4 was rolled, 5, until it goes all the way up to 12 was rolled. Then for this next one, this will tell you how many times it was rolled, because that's the die result is where we counted the rolls of each possible value. And then over here, this percent point to F will give you the practical probability that we stored in this practical probability array. And finally, when we put these percent, that flag is just to show to put the percent sign instead of one of these flags. That's really all it is. We want to put a percent sign. We're not trying to start up a new flag. Percent. That's what it is. Just like how when you are writing in a string, it would be like backslash quote to put a quote inside a quote. It's percent to put a percent sign inside a formatted print. If that's way too much for you to remember right off the bat, don't worry. I know it's a lot. I just keep on saying percent. But anyway, before I go too long, let's just run this, and it'll take a bit. What I do? Result semicolon expected. Oh, in dice.java, let's see what I do here. Oh, I forgot to put a semicolon here. That should hopefully be the only error. Oh, nope, it's not. I cannot find the symbol I in 18. Oh, and that's because I put a semicolon here for no good reason. Alright. So I took a semicolon out and I put a semicolon in. Oh well. Alright, so here's what we have. For 100,000 rolls, 2 was rolled blank many times, giving it a practical probability of 2.81%, 5 blah blah blah. The whole point of this exercise is to randomly roll 100,000 times and see if our practical probabilities matched with our actual theoretical probabilities that are calculated through math. And you can see these numbers match pretty closely to what we have here. They're slightly off. And the reason is we don't have a really large sample size. We only have 100,000 rolls, which it might be surprising is not very many. So I'm going to throw another 0 in there and do 1,000,000 rolls and see if these numbers, now when I run again, are any closer to the numbers we have here. And you see they get a lot closer. All right. This one was 16.7 something, and now it's 16.63, which is somewhat closer to that. You know, still a little bit off. But you know what? We can improve this. Let's bring it to 10,000. Sorry, 10 million. That can't. All right. And again, it'll get slower the more rolls you end up doing, but it'll be a better result. And you'll see that these are even more close. Now, each of these numbers, if I'm looking at each of these numbers, they're only about 0.01% away from our theoretical probability. And that's pretty much as good as it's going to get. You know, you might end up, if you just do it randomly, getting exactly this just by happenstance. You know, the probability is random, so there will always, there will usually be some, you know, deviation from what we're expecting. But this is a really good exercise in trial versus our expectation. And you can see we actually match up pretty well. Well, anyway, guys, I know this is one of the longer videos. I wanted to make it shorter, but I, you know, ramble on and go slowly. Hopefully you watch this on double time. All right, guys, I will see you in the next one. Have a great day. Don't forget the attendance.